For number 8, we have another limiting reagent problem because you're given 2 of the reactants. The student reacted 1.5 grams of salicylic acid. All right, so 1.50 grams of salicylic acid. I'm going to abbreviate that SA. And then I have 2 grams of acetic anhydride. And it wants to know the theoretical yield and the percent yield for this experiment in making aspirin. So I was able to make, this is the aspirin, and I was able to make 1.50 grams. All right. When you actually do a synthesis or make something in the lab, you don't always get the amount you want. All right. The calculated amount is the theoretical yield. The percent yield is the actual, comes from the actual yield, how much you can make in the lab. So let's test to see how much we can make, how much aspirin we should be able to make in grams. All right, so 1.50 grams of salicylic acid, and that is 138 grams per mole of salicylic acid. And it's all a 1-to-1 ratio for every 1 mole of aspirin. And aspirin is 180 grams per mole. I get 1.96 grams of aspirin. All right. If I use 2 grams of the acetic anhydride, its molar mass is 102 grams per mole. It's a 1-to-1 ratio, so for every 1 mole of acetic anhydride, I can make 1 mole of aspirin. And for every 1 mole of aspirin, I have 180 grams of aspirin. So the amount I can make with 2 grams is 3.53 grams of aspirin. So this one is not the one we make. This is what our answer is. So our salicylic acid is limiting reagent. All right, so this is our theoretical yield. All right. Now, percent yield, you take your actual, so your lab is, this is what you make in the lab. Made in lab. All right. Divided by your theoretical, which is 1.96. This is how much you should have been able to make. Well, let me write theoretical here. Theoretical times 100. All right, so what that is 1.50 grams over 1.96 grams times 100, and that gives me a 76.5% yield, which is the answer to the second question.